incredibly important as it allows us to define the concept of a temperature scale. It states, if two systems are each in thermal equilibrium with a third, then they are also in thermal equilibrium with each other. For example, consider two separate cups of boiling water. If we place a thermometer in the first cup, it gets warmed up by the water until it reaches 100 degrees Celsius. We now say that the thermometer is in thermal equilibrium with the first cup of water. Next, we move the thermometer to the second cup of water and it continues to read 100 degrees Celsius. The thermometer is therefore in thermal equilibrium with the second cup of water. Using the logic of Zeroth law, we can conclude that the two separate cups of boiling water are in thermal equilibrium with each other. The Zeroth law enables us to use thermometers to compare the temperatures of any objects we like. Now, let us move on to the first law of thermodynamics. The first law of thermodynamics states that heat is a form of energy and thermodynamic processes are therefore subjected to the principle of conservation of energy. This means that heat energy cannot be created or destroyed. It can, however, be converted to other forms of energy. Like the Zeroth law, which defined the useful property temperature, the first law defines another useful property called energy. The first law can be expressed mathematically as delta U equals Q minus W. Here, delta U is change in the internal energy of the system. Q is the energy transferred to or from the system, and W is the work done by or work done on the system. To understand this law, let us consider a piston weight system. Imagine there is some gaseous matter below that piston. If we give some amount of heat to these gaseous molecules, their internal energy increases, which means the temperature of the system will increase. More temperature means the molecules or atoms will move at much higher velocity. This is the increase in internal energy. This increased random movement also increases the pressure in the system and therefore it moves the piston upwards. So essentially the system is doing the work. Here some part of the heat given to the system has increased the internal energy and some part is used to do the work. The heat energy Q is equal to the change in internal energy of the system plus work done. By rearranging, the change in internal energy can be seen as heat supplied minus work done. So, this is another way of conveying that energy is conserved. This equation is valid in the case of closed systems. So, that is all about first law. To sum up, in this video, we learnt about the Zeroth law, which defines temperature and temperature scale, and then the first law of thermodynamics, which defines energy and upholds the law of conservation of energy. In the next video, we look at the second law of thermodynamics. See you there.